the Indian ambassador, who was very keen to also join us, so he flew in from Santiago as well to be there for the Eclipse expedition. Okay, since this is a very general crowd, I'm not going to go into details. For those of you who are interested in such things, you can just read them. I'm not going to spend too much time on them. But basically, it just, we did, again, spectroscopy in this experiment, and in this, for this eclipse. But the new element, every eclipse, we've introduced a new experiment. So we've been observing the green and red lines, but this time we also decided to look at H-alpha because we wanted to study the chromosphere. So this was, for the first time in our experiments, we had spectroscopic and to study the chromosphere in H-alpha. So these are basically, this shows you, we had two spectrographs. This was for doing the emission lines, the green and red lines. This is for the H-alpha. And that shows you what the sky looked like again. I'm going to skip that. Okay, I think I should also skip that. So let me just, for those of you who have sort of a technical interest, what have we achieved? And this is one of the questions which, as I told the people ask, have you really achieved anything which has contributed towards, in a fundamental way, towards our understanding of the sun? Well, I would say we are making some effort in that direction. That is, one is, as I said, that we have all our experiments have confirmed the existence of waves in the corona. The periods, we believe, are in the range between 30 and 60 seconds. All these experiments confirm this. And we have done it in two ways. First, the first experiment, which we did from Turkey, was we did it through photometry, basically, intensity. And the second independent confirmation of this result comes from spectroscopy, again, by looking at the lines and the Doppler shifts. So we have been able to confirm the existence of these waves in the corona. I'll skip that also. We also observed, but there was not really much, there was not really many scientific experiments, but just more for the beauty of it. We observed the annular eclipse of 15 January last year, and we went to Kanyakumari. We also have a radio telescope at a place called Gauri Bidanur, which is near Bangalore, and from there also some observations were taken. So this is a picture which actually provided to me by Mr. Pandey, who was the director of the Nehru Planetarium, which I think is a nice picture of the annular eclipse. Now, just moving away from eclipses, I just want to, in the few minutes that I have left, I want to tell you about some of the new programs that we have started on in India. One of them is we are building a coronagraph, a space coronagraph, which will be launched in about 3 years from now on Aditya 1. Many of you might have read about this in the newspapers, that the Indian Space Research Organization has approved this program. The Indian Institute of Astrophysics is the nodal agency for executing this project. So, again, the objectives of the space coronagraph are related to trying to understand the detailed conditions in the corona. I'm not going to read all of them. You can see them. An important application of this study is, of course, space weather, to be able to understand coronal mass ejections and their properties. And this helps in being able to, as far as the space climate is concerned, the effect on satellites and so on. So this has also some direct benefit as well for concerning satellites, etc. And in the other program, which I'd like to talk to you about, is that we have submitted a proposal to the government of India to set up a large solar telescope of 2-meter aperture. And if this project is approved, which we are hopeful it will be, this would be the largest solar telescope in the world for several years to come, at least till the Advanced Technology Solar Telescope comes. So we hope to be able to realize this project in about 3 to 4 years, to complete it by 2016. And this shows you a place where this is the Pangong Lake in the Jammu and Kashmir area. It's at an altitude of 4,500 meters. This is a sort of an artist's impression of what the telescope would look like on the shores. These are actually places where we conduct experiments, but this is what shows you what it would look like. So this is this beautiful lake. It has a little protrusion out here, and we hope to put it there. And the idea is that a water body provides you a thermally stable environment for carrying out solar studies. I think I should probably just skip this, but this just tells you what we're trying to study. We're trying to study effects of magnetic fields, how magnetic fields on the sun are generated. We're trying to understand the properties of sunspots, the details, and we're trying to understand the properties of the different types of magnetic structures. This is an image taken from space, from the Solar Dynamics Observatory, showing you all the different types of, a range of phenomena that takes place, flares, coronal mass ejections, and so on. One of the novel features of this telescope is that in the day it will study the sun, and at night it will study the stars. So there will be no downtime. It's a 100% duty cycle. You will be using this telescope for doing both solar astronomy as well as for doing nighttime observations. I'll end on what we've been doing in terms of public outreach. And the Indian Institute of Astrophysics has been participating in a very active manner in the International Year of Astronomy. And this shows you a float which was actually, this was executed by us at the Republic Day parade of 26 January 2009. And it showcases basically the indigenous efforts in astronomy. This is a model of the giant meter radio telescope, which is functioning near Pune, which was developed in India. And the other is a model of the 2.3 meter Venubapu telescope, which is in Kavalur, out just not far from Bangalore. So this was what was accepted by the Republic Day committee, and I think it went off very well. We've also participated in another cornerstone project of the International Year of Astronomy called 100 Hours of Astronomy, in which we participated in the Hanle Chandra telescope. We have a 2-meter telescope in the Himalayas, and that participated in a program called Around the World in 80 Telescopes. So there was a live webcast which was seen by people all over the world. I don't know if anybody here saw it, but this was, from what I hear, it was seen by a very large number of people. And finally, I should also mention that we have developed a low-cost 10-centimeter telescope, which we have been distributing to schools, colleges, institutions, in fact, to anybody, as long as our stocks last. Now, anybody who wants a telescope can just go to our website and just fill in the form and order one. So we are involved in many ways, and in public outreach. I should also mention that I hope that this will also be the beginning of a collaboration between the government-funded bodies like the Indian Institute of Astrophysics and other institutions, the National Council of Science Museums, and space. And I think that the transit of Venus is one occasion where we already had discussions on what kind of things we can plan for it. So I'm very hopeful that this will lead to a very positive outcome. And I would like to once again thank you very much for your attention.